Take a moment to look up at the night sky on a clear evening. And if you know where to look, you'll spot Mars, a tiny reddish point of light. It's a world that's captured our imaginations and fascinated us for centuries, a beacon in the cosmic dark. We've sent robots, our mechanical emissaries, to explore its surface, to analyze its soil and scan its horizons. But what if we could do more than just visit and observe from a distance? What if we could truly make it our own? What if we could transform Mars, this barren landscape, into a living, breathing planet, a second Earth? This is the bold, ambitious, and perhaps even audacious idea of terraforming. It's about fundamentally reshaping Mars, altering its environment to support life as we know it. The science involved is undeniably daunting, presenting immense challenges, but it's not fundamentally impossible. We're constantly learning more about how to manipulate atmospheres, how to thicken them, and how to make them breathable. And we're gaining a better understanding of geology and how to influence planetary surfaces on a grand scale. Imagine, if you will, standing on a Martian hillside, feeling the red soil beneath your feet, breathing fresh, clean air that you don't need a suit to survive in, seeing rivers flow, carving their way through the Martian landscape, and watching clouds drift lazily overhead, painting shadows on the ground below. The ultimate goal isn't just mere survival within the confines of domes and habitats. It's about achieving true freedom, living under an open blue Martian sky. Mars, in its raw state, already possesses the fundamental raw materials we need. Vast reserves of ice, a crucial source of water, an atmosphere rich in carbon dioxide, and a wealth of untapped minerals beneath the surface. Our challenge, our grand endeavor, is to unlock and awaken its hidden potential, to transform it into a vibrant world. Terraforming Mars would undoubtedly be humanity's single greatest engineering feat, a project unlike any other we have ever undertaken. It would stand as a lasting testament to our insatiable curiosity, our boundless ingenuity, and our unwavering drive to explore the cosmos and push the boundaries of what's possible. Terraforming, at its core, is a grand vision. It means fundamentally reshaping another world to resemble Earth, our home. It's about taking a planet that's currently inhospitable to human life and transforming it into a place where we can thrive. It's not about creating a perfect carbon copy of Earth exactly, but making Mars Earth-like enough for us to live there, to establish colonies, and potentially even build a new civilization. The process involves a multitude of steps, starting with thickening the atmosphere, raising temperatures across the planet, and carefully introducing the right mix of gases so we could eventually breathe the air without needing a spacesuit, a monumental achievement in planetary engineering. Think of it as restoring a derelict house, assessing the damage, fixing broken systems, and ultimately making it livable again. Mars's broken systems are readily apparent. Its thin atmosphere, frigid climate, and the conspicuous absence of liquid water on its surface. Our job then, should we choose to accept it, is to become planetary engineers, tackling these challenges step by step, project by project, over generations to come. Each change we implement triggers new challenges. Warming the planet leads to the release of trapped gases, which in turn thickens the atmosphere, which then leads to even more warming in a continuous cycle. Carefully selected microbes could play a crucial role in helping make the soil fertile, paving the way for the introduction of plants and eventually, the establishment of a self-sustaining ecosystem. It's a delicate, long-term transformation, a process that will require patience and unwavering dedication, an epic symphony of science, engineering, and a testament to humanity's boundless ambition. The first crucial step is warming Mars, a planet which is currently colder than even Antarctica. We'd need to trigger a significant greenhouse effect by releasing carbon dioxide trapped deep within the polar ice and soil. Giant orbital mirrors could focus sunlight intensely on the poles, sublimating the ice and subsequently thickening the atmosphere. Factories could pump out potent greenhouse gases, accelerating the entire process. As Mars warms gradually, water ice would melt, and eventually, rivers would flow, and ancient lakes could refill once more. With liquid water present, life becomes possible, starting with microbes, then plants to produce vital oxygen. Each step builds carefully on the last, slowly transforming Mars from a completely frozen desert to a world brimming with potential for life. The ultimate dream, a beautiful blue sky, freely flowing water, and the very first signs of a thriving living planet. The obstacles to transforming Mars into a second Earth are immense. presenting a series of complex engineering, scientific, and ethical challenges that must be addressed. It's not just about reaching the planet, it's about making it habitable for future generations. One of the most significant hurdles is that Mars lacks a global magnetic field, a protective shield that Earth possesses. As a result, its atmosphere is constantly vulnerable to being stripped away by the relentless solar wind, a stream of charged particles emanating from the sun. This poses a major threat to any long-term terraforming efforts. One proposed solution involves creating a giant artificial magnetic shield in space, strategically positioned to deflect the solar wind and protect the Martian atmosphere from erosion. The technology required for such a feat is currently beyond our reach, representing a significant leap in engineering and material science. However, it remains a theoretical fix for a fundamental problem, offering a potential pathway towards a more sustainable Martian environment. The timescale required for terraforming is daunting, potentially centuries or even millennia of sustained effort, demanding unwavering commitment and perseverance. Achieving this monumental goal will necessitate unprecedented global cooperation and a shared commitment that transcends generations. Furthermore, there are profound ethical questions that we must confront. Do we as a species have the right to fundamentally alter another world, potentially disrupting its existing ecosystem, however simple it may be? What if life, in some form, already exists there, waiting to be discovered? We must carefully balance our ambitious dreams of transforming Mars with a deep sense of responsibility, ensuring that we don't inadvertently destroy the very thing we seek to create, a new home for humanity. The endeavor of terraforming Mars is not just a scientific undertaking, it's a profound test of our vision, our patience in the face of immense challenges, and our unwavering commitment to ethical principles. The journey to transform Mars will undoubtedly challenge us as much as the destination itself inspires us to reach for the stars. Why terraform Mars? For survival, innovation, and inspiration. Earth is vulnerable. Terraforming Mars is an insurance policy for humanity. The technologies we develop could help us manage Earth's climate and resources better. The challenge would unite us, pushing the limits of our creativity and cooperation. It's about more than science. It's about our destiny as explorers. Will we remain earthbound or reach for the stars and become a multi-planet species? The vision of a living Mars is a call to adventure, a future worth striving for.